Good morning, students.
Good morning.
Good. So today we discuss upon a topic Data Encryption Standard. So before starting that topic, anyone recap what are the topics we discussed in the last class, previous classes? Samiksha?
Okay. So until now we saw the basics of cryptography, and then we saw the type of cryptography which included symmetric, asymmetric and hash function. And then we saw about the modular arithmetic and its types, which included addition, subtraction, multiplication and division. And then we saw about the binary GCD algorithm. And after that we saw the Chinese remainder theorem. And then we saw about crypt analysis and brute force attacks. And then we saw about the classical encryption techniques, which included substitution and transposition. Under substitution we saw the Caesar algorithm, monoalphabetic, playfair and Hill cipher. And then under transposition we saw about rail fence and row column.
Okay, good. Okay, so we have already discussed many topics. Now, majorly we can classify the cipher techniques into two ways. One is a transposition technique, second is a substitution techniques. So today we discuss upon data encryption standard. So this algorithm, it combines both types of ciphers. It combines both the substitution technique and the transposition technique. Right. So in data encryption standard, it is a block cipher. Block cipher is nothing but this algorithm converts the entire block. It encrypts 64-bit block plain text into cipher text. So here, we all know the key is required for encryptions and decryptions. So this is symmetric. The common key is used for both encryption and decryption. So that's why we call this as a symmetric block cipher. Right. So here input plain text is 64-bit and also the key is also 64-bit. If we feed input 64-bit plain text, this algorithm encrypts that into 64-bit cipher text. Right. So there are 16 rounds of encryption used here. At the end of 16 rounds, we get the encrypted cipher text. So here the 64-bit round key. So for all 64 rounds, we are using 64 round keys. Each round key is different. So these keys generated using key scheduling algorithm. We discuss one by one next. So this is the complete working of data encryption standard. So here this side input is 64-bit plain text. The right side it is a key scheduling algorithm. Right. So here this round, each round we call it as a Mangler function, otherwise Fiestal structure. So the combination of substitution and transposition done in these rounds, in these 16 rounds. Right. So here the plain text enters into this in this position. Here the plain text is initially permutated with the according to that predefined permutation table. So it is already predefined table is available. Okay. So according to this table, the input plain text 64-bit is permutated. That is the bit is already shuffled. Right. Then again the shuffle, that is the permutated input comes to round 1. This round 1 gets a 48bit round key. So how do we get the round key? Just look into it. So here the key is 64-bit. Right. So this 64-bit is again permutated using permutated choice 1. Here 64-bit is reduced to 56-bit. Already it is also predefined permutation table. Using that table, this 64-bit is reduced to 56-bit. After that, this 56-bit is divided into two. Left half 28, right half 28. Okay. So for each round it gets shift. One bit it gets shift. For round 1, 2 and 9 and 16th round it gets single left shifter. For the remaining rounds it gets a 2-bit left shift. Right. So look into this first round. So here in the first round the key gets single left shift and this 56-bit come to permutated choice 2. Right. So this in this permutated choice 2, this 56-bit is contracted, that is reduced to 48 bits. In this stage, every 8 bit is reduced. So here we get 48-bit round key. This key we call it as round key. So round key 1 round key 2 is K2, round key 16 is K16. We are representing like that. Right. So the key is generated according to this key scheduling algorithm. Then the input plain text goes through all the 16 rounds, and finally the 16 at the end of 16th round, the 16-bit plain text, that is left half, right half, is divided into 32. These 32 gets swapped and goes to inverse initial permutation. Here it is initial permutation we do, and again it is reverse of initial permutation. Finally we get 64-bit ciphertext. So this is the main working of Data Encryption Standard. We discuss each and every block in the consecutive classes. Thank you. Anyone recap of today's class? Dinesh?
So we see that the DSA stands for Data Encryption Standard. So it is a combination of both substitution and transformation. It is a block cipher. It has 64-bit. It converts 64-bit converts to 64 ciphertext with the help of permutation table. The working of this block cipher is it has 16 rounds. From round 1 to round 16, it will be divided into two, left shift and right shift. In left shift it has 32-bit and right shift it has 32-bit. And after that it will swap and it will continue to initial permutation, and we will get the 64-bit plain text.
Okay.